Hanoi, the capital of Vietnam, currently has a rapid increase in passenger transportation. To reduce traffic congestion, the Nhật Tân Bridge project was initiated with support from the Japanese government. The bridge will provide 2 standard lanes, 1 bus lane, 1 mixed lane, and 1 sidewalk in each direction. The Nhật Tân Bridge project is divided into 3 packages. The main package named Package 1 covering the construction of the main bridge, the North Approach Bridge, and the North Dye Bridge, with total length of 3,080 meters. Main bridge is a 6-span continuous cable stay bridge with 4 300-meter main span and 2 150-meter end spans. The cable arrangement is fan type, applied for most long-span cable stay bridges. The pylon is an A-shaped structure supported by steel pile sheet pile foundation. The highest pylon extends 111 meters from the pile foundation or 74 meters from road level. The superstructure consists of steel girder and an overlaying 26 cm thick concrete deck slab. A total of 220 cables are used to support the superstructure. Each cable is composed of galvanized steel wires compacted and packed in protective coloring. The steel pile sheet pile was applied for the pylon's foundation for the first time in Vietnam. For the ends pier, ordinary cast-in-place foundation was used. The reinforced concrete pylon legs are cast in 34 faces using self-climbing formwork system. The stay cable steel anchor boxes are erected segment by segment and then embedded in the concrete stem near the pylon top. Temporary supports are used in the initial stages of erection. The steel girder is erected and followed by placing precast concrete deck slab. Joint concrete is then cast in place to join the concrete deck slab to the steel girder. Equipment and machinery for the cantilever erection are then prepared on the deck slab. Cantilever process involves in repeating the following works as cycle: erection of steel girder, placement of precast deck planners, installing and tensioning of stay cables, cast in place concrete joint. For erection of the main span on each pylon, 10 cycles are repeated. The cantilever process is ended by closure works of the span. The North Approach Bridge includes 31 continuous Super T spans. Each span is 40 meters length and is made of 15 Super T beams with cast-in-place deck slab. Each pier is supported on concreted boring pile foundation. 2 columns shall be built up from the pile cap and end with the pier head. The erection of the Super T girder shall be performed in 2 ways. The Super T girder shall be moved to erection location by using 2 customized shactors. In the first method, 2 mobile cranes shall lift and install the girder. This method is applied where the ground conditions allow. One by one, girder shall be erected from G1 to G15. The second method of erection uses a gantry crane. The gantry crane is supported on rails fixed at the pier center. After lifting the girder off the transport tractors, the cranes move transversely to the setting location. The girder are then placed at the designated bearing. One by one, the remaining girders are transported and erected. The North Dye Bridge is a 7-span continuous concrete box girder bridge. The superstructure's cross-section is a box girder with overall width of 33.2 meters. Each pier is supported on concreted boring pile foundation. The pier's columns shall be built up from each pile cap. Scaffolding construction methods shall be applied for 4 spans of the box girder bridge. For continuous spans adjacent the dike rope, cantilever erection is to be applied. Scaffolding method is used for the superstructure above the pier. Thereafter, movable temporary support for scaffolding and formwork known as travelers are installed. The travelers are then used in the construction of 4-meter segments on either side of the pier. Closure work are performed using scaffolding method and self-supporting formwork. Accessory works including weathering surface, road marking, road lining, and monitoring shall be performed before completion of bridge construction.